Let's look at one more example to understand CFG to PDA conversion. Let's take this example a power n, b power m, c power m, d power n, where n comma m is at least 1. As you can see, this and this there is a match, this and this there is a match. So corresponding CFG is S implies S A S D. Using this, you can pump A and D equal number of times. So you will get A power n, D power n. Now to switch and generate this part, what we do is the following. So S implies A, capital A, D, and A implies B, A, C, and when we want to terminate, we say A implies BC. And if you want AB, CD, start with this, then take this. And you want 4 times A, then take this one 3 times. 4th time you take this, then use this for B power n, C power n. Now, given this, we want to construct an equivalent PDA. Supposing I take a string like AA, triple B, triple C followed by this. How exactly we trace to derive this using this grammar, that simulation is what we are going to write as sequence of transitions. So delta of Q naught comma, without reading epsilon, without reading any input, which is epsilon, and top symbol is Z naught, we go to Q1, we push the start symbol. So initially it will be Z naught, then we push S onto the stack because S is the start symbol. So the first transition is always push the start symbol. Then what we do, we write productions for all non-terminals staying at Q1 without reading anything. If the top symbol is yes, then we say Q1 comma, write the corresponding right hand side. It is ASD, Z naught, or you are in Q1 epsilon, it is yes, and you get Q1 comma, in place of yes you write ASD. So top symbol is yes, we replace that by ASD, and the top symbol is yes, we replace that by AAD. Now staying at Q1, we may see other non-terminals. For example, in this case capital A, this says Q1 comma BAC, or we may see this, then it is Q1 comma epsilon comma, this is Q1 comma BC. Now with the help of Q1, you may come across non-terminals. In this case it is S or A, then replace that with corresponding productions on the right. Now push operation is done. Now we may come across terminals. What are all? Maybe it is A, top symbol is A, then you go for EPOP. Or when you are at Q1, you may see a B on the input tape, top symbol is also B, then go for POP. Or it is Q1 comma C, then go for POP. or it is Q1 comma D, then go for pop. So now with the help of Q1, you ensure if it is a terminal, perform push. If it is a non-terminal, perform pop. As you can see, this brings non-determinism. This also brings non-determinism, which is inevitable. When you have top symbol as A, and if there are at least if there are more than one production, so naturally you will have to come up with a non-deterministic machine. It has to non-deterministically guess which is the production to be replaced with. Now, as part of terminals, we go for pop. Now, finally, you have delta of Q1 epsilon comma Z naught. We go to a final state. Fine. Now, if you look at this string, starting from Z naught, initially it will be Z naught. Then we push yes. Next, what we will do, we have to non-deterministically guess whether to take this or this. So let me replace this by ASD. So it becomes Z naught ASD. Fine. Now top symbol is D. This says perform pop. So it becomes Z naught AS. Again, we need to non-deterministically guess whether to take this or this. Now in this case, if I choose this, what is that I'll get? I'll get AAD. Then we will have A. With this A, you can get into this part. So what I do, I replace this one by A, capital AD. Next we go for a pop because top symbol is a terminal. Next, top symbol is a non-terminal. I have to decide between these two, which one to choose. Let me choose this for push. So what we will get is AA, then we will get BAC. Now top symbol is a terminal, go for pop. Now next top symbol is a non-terminal, so we have to go for a push. So let me choose the same thing again. Fine. Now top symbol is a terminal, go for a pop. Next one is a non-terminal. Now between these two, I non-deterministically choose this. So what I'll get is AA triple B on top of is C. Now go for a pop. So followed by pop, pop, pop using this one. Now we pop these two using this. I am in Q1, top symbol is Z0, reach the final state. So what is this telling you? That you give me an arbitrary string, the way we parse this, okay, using this grammar, the same thing we simulate or we mimic using these transitions. Okay, so that's how we say an equivalent PDA is constructed. Fine. So otherwise, when you look at CFG is actually looking at the underlying set. It is looking at the underlying set, how exactly strings are formed, and using base string, we try constructing other strings, so we obtain a recursive formula. And on the other side, PDA says you perform push for certain symbols perform pop, and how do you relate these two? So on one side, the grammar is constructed by looking at the pattern, by looking at the underlying set, and on the other side, push down automaton is constructed with the help of how exactly you manipulate the step, whether you go for a push now or pop now. So now one has to relate these two. What we do, and after all, we are trying to construct CFG or PDA to accept a set of strings. So what, just focus on what is that we are doing as part of this. Focus on how exactly a string is generated following leftmost derivation. Okay. And the same thing, if you try simulating with respect to PDA, you are actually obtaining an equivalent PDA. That's precisely what we have done as part of this procedure. And we have explained our construction using two examples. One in which we had only one start symbol, only one non-terminal, which is S itself. And in this case, there are two non-terminals. So essentially, for all terminals, pop, for all non-terminals, push, and replace top symbol with what is there on the right. And this one is straightforward. Now with this, one can simulate, but only thing is, it will be a non-deterministic mission, because we may find more than one productions for a given non-terminal. If it is unique, then it becomes a deterministic PDA. Otherwise, by definition, we only obtain a non-deterministic push-down automata. Using this, okay, one can actually construct using a different approach, one can construct a deterministic PDA, but using this approach, we obtain a non-deterministic PDA. Fine. The other question is equally interesting. Given a PDA, how do we obtain an equivalent CFG? So something like this is given to us. How do we obtain a grammar like this? Okay. So now this will, just like the way we have done this, when we want to relate this with an equivalent CFG, again we go for derivation. How exactly an arbitrary string is simulated by this PDA, the same thing we try converting into a grammar. So which means when we write grammar, even some of these terms will appear as non-terminal and protections and so on. That's pretty interesting, which we shall see next. With that, we have formally established PDA and CFG are equivalent. Okay, and for this, an equivalent CFG can be constructed. For a given CFG, an equivalent PDA can be constructed. So we shall discuss this next.